Okay, so last section we'll take a look at, that'll be on the test on Friday, will be 2.2, same section really, it's just the third part of that section. Okay, so the big difference is we're going to look at finding the coordinates for angles that are multiples of the 30, 45, and 60. So we're not necessarily going to be just in the first quadrant. Okay, not much changes when you're in the other quadrants. Okay, we kind of took a quick look at it yesterday. But I'll probably start out with like a review problem from yesterday, and then we'll get into multiples. Okay, so we're still using the 30, 60, 90 and the 45, 45, 90 triangles. So when I'm dealing with the 45, 45, 90, what are the numbers that come up there for x and y? So there's three numbers you have to remember. Yep, when you're dealing with the 45, 45, 90, that's square root 2 over 2. What are the two other numbers that come up when you're dealing with the 30, 60, 90? Gabe? 1/2. And somebody else give me the other one? Devin? Square root of 3 over 2. Okay, you have to remember those three numbers we just said. Yeah. All right, so let's, does anyone want me to start out with the review problem first, or we do it second? Does that matter? No? Okay, we'll do this one first, and then we'll do the review. This is a review problem. We'll do that one second. All right, so I want to find the 6 trig functions of 135. Okay, the other thing I'm going to do a little different today is, after we do the 6 trig functions for this one, in future problems, I'm just going to focus on one of the 6. Okay, that's more how it's going to be on the test. You're not going to have to do all 6 in the same problem. You're going to have a problem, and it's just going to ask for one of them, okay, like this one. All right, so first thing we want to figure out is roughly where 135 is. So that's 0, 90, 180, 270. Okay. What quadrant is 135 in? Quadrant, which one? Yeah, it's in quadrant 2, upper left. These are your quadrants if you want to number them. And there are basically 3 places it could be. Closer to 90, closer to 180, or right in the middle. Where's the 135? Yeah, it's right in the middle. Okay, so we're going to put 135 right there. Okay, after I put my point, what's the next thing I always do in the diagram? Yep.
Draw the triangle.
Yeah, we're going to draw the triangle, so we need 2 sides. Draw a line from your point to the origin, and then draw another line from your point down to the x-axis. Okay, there's your triangle. Okay, that's a 90. All right, so let's just take a look and see if this is the 45, 45, 90 or the 30, 60, 90. What do you have to add to 90 to get to 135? You have to add 45. So that means this part out here, which is the same as this part right here, that part is 45. So what is this part on the inside? It's also 45 because the quadrant right here makes a 90. All right? So this angle at the bottom is 45, which means the angle at the top is, yeah, it's also 45. Okay, so the point when we work with 135, we're using a 45, 45, 90 triangle. Next thing I'm going to do is label the 2 sides. Okay, Ariel, how long is the bottom side? So 1 would be the hypotenuse. Not a half. That is a number we're going to use, but not with the 45, 45, 90. Remember the number, I think Jamel or Gabe, one of them said it? Okay, what's the number that we always use with the 45, 45, 90? It's the square root 2 over 2. So this is square root 2 over 2. And what about, Jacqueline, what about the height? It's also square root 2 over 2. This is the same triangle we drew yesterday, except now it's flipped into the second quadrant. And when we write down the coordinate, we have to take into account that it's been flipped into quadrant 2. So anyone think they could give me the coordinate for 135? Thanks so much. Gabe? Yeah, that's the only thing that's going to change today, is sometimes you're going to have a negative. Okay, so this time, left, square root 2 over 2, that's negative, and then up, that's still positive. So now we do all 6 trig functions just like normal. Just remember that the x value is negative. All right, so Sydney, what's my sign here? Which one? Yeah, it's the square root 2 over 2. It's the y value, it's positive. Brianna, what about my cosine? Yep, that's the x value. This time it's negative square root 2 over 2. And David, what's my formula to find tangent? Y over x. So just imagine we put a division line in right there. If you divide these two, what do you get? Yeah, you get negative 1. We're dividing two things that are the same, except one's positive, one's negative. Okay, now we'll find the last 3. Wendy, what would be my cosecant? Yep. Any question on how she got square root of 2? So she had to do 2 things to get that. She flipped the sign, but then the root went in the bottom and she moved it to the top. Okay, Riley, how about my secant of 135? Yeah, it's the sine and the cosine. The only difference between them is one's positive and one's negative. So that's the same between cosecant and secant. They're going to be the same thing, except one's positive, one's negative. And then the last one, Becky, what would be the cotangent of 135? Yeah, negative 1. Okay, negative 1 is the other number besides 1 that you flip it, and it stays the same. Okay, any questions on how we did any of those 6 trig functions? Okay, this is the only problem today that I'm doing all 6. Everything else I'm just going to do 1. Okay, so no questions? All right. So let's look at this one. Cosecant of pi over 4. Now, if you're starting to get comfortable with some of these, you might already know what pi over 4 is, and then you might already know the coordinates, so you don't even need the picture. Does anyone think they already know the coordinate for pi over 4? Yep, nice. Yeah, square root of 2 over 2, square root of 2 over 2. Pi over 4 is a 45-degree angle. If you didn't know that coordinate, what you do is what I'm doing right now. Put your point, then draw your triangle, and then you could figure out this is a 45-degree angle, because that's what I labeled it as right there, and that's a 45-degree. Now from here you have to know the lengths of the sides in a 45, 45, 90, and they're both positive. Positive, positive. Okay, so this time they want the cosecant. Gladdy, what's the formula for cosecant? I want to find, what's the formula for cosecant?
Is it 1 over y?
Yeah, that one's 1 over y. which means take the y value and flip it. And we've done this one a lot, so anyone think they can tell me what you get when you flip that final answer? Yep. Yep, it's just the square root of 2. Okay, and for this problem, that's all they asked for. So we're done. Okay, any questions on the cosecant of pi over 4? Okay, that's a review problem from yesterday. All right. Let's look at sine 225. Before I even draw it, does anybody have a guess if 225 is a multiple of 30, which would mean it would be the 30, 60, 90? Or is that a multiple of 45? Yeah, how do you know that can't be a multiple of 30? It ends in a 5. Multiples of 30 end in a 0. Okay? So that's going to be a multiple of 45. We just have to figure out what quadrant it's in. What quadrant is 225 degrees in? Jacqueline? It's in the third. And because we said it's a multiple of 45, it's exactly in the middle. Okay, if you don't believe me, just check it. Find the average of 180 and 270. It's 225, right in the middle. Okay, so here's my 45, 45, 90 triangle. So what's going to be the coordinate for 225? How about Mercedes? Can you tell me what the coordinate would be?
Negative square root of 2 over 2.
Yeah, both of the sides are square root 2 over 2, but you've gone left and you've gone down. So they're both negative. And now this problem is asking for just the sign. Okay, so what's the sine of 225? Yeah. Okay. Yeah, it's the y value, which in this case is negative square root 2 over 2. Any questions on that? Okay, so we did a 45 in the first quadrant, the second, the third quadrant. You can probably guess what's going to happen here. Okay, Graham, what might I want to do first with that? Okay, ultimately I want to get the coordinate. And how would you get the coordinate using 7 pi over 4? Okay, so let's change to degrees. And if you do that out, it's going to be 315. Anyone need me to show them how to change the radians to degrees? No? Okay, so if you do that out, you're going to get 315. And I've asked the same question, but we already kind of know the answer from the last problem. This can't be a multiple of 30 because it ends in a 5. So it has to be a multiple of 45, unless it's a problem I'm having you do on the calculator. And we're not there yet. Okay, so it ends in a 5. It's got to be a multiple of 45. What quadrant, James, what quadrant is 315 now?
It's in the fourth.
Yeah, it's in the fourth. Okay. It's right exactly in the middle. So again, we're dealing with a 45, 45, 90 right triangle. Is there any questions why it's not the 30, 60, 90? Why that number is not a multiple of 30? We talked about that in the last problem, but it's okay. All right, so what's going to be my coordinate, bless you, for 315? About Henry, can you give me that coordinate?
Square root 2 over 2 minus square root 2 over 2.
Yeah. Still the root 2 over 2's because you're dealing with the 45, 45, 90, but x is positive, y is negative. And now they want the cosine. So Kylie, what would be the cosine of 7 pi over 4? Yeah, it's the x value, which in this case, if you mix them up, you would get it wrong because one's positive, one's negative. But she did it perfect. Root 2 over 2. Okay, so we basically just went through a 45-degree angle in each quadrant. So if I give you a 45-degree angle in the first quadrant, I could ask you for any one of the 6 functions, sine, cosine, and so on. If I give you the 45 in the second quadrant, that's the 135, and I could ask you for any one of the 6 about that one. Okay, same thing in the third and in the fourth quadrant. So with just a 45-degree angle, there's 24 different questions I can ask about it. Any one of the trig functions, there's 6 in any one of the 4 quadrants. 6 times 4 is 24. Okay.
The tangent quadrant 3, would that be negative 1 instead of positive 1 instead of both negative?
Yes, if you had the tangent, like in this problem, the tangent of 225 would be y divided by x. Since they're both negative, they divide and become positive. So the tangent of 225 is positive 1. Any other questions about working with 45? I think the 45 is a little bit easier because both the numbers are always root 2 over 2. You can't really mix that part up. When we start working with the 30s and the 60s, then we have to make sure we get the order correct. Okay, 120. Is that a multiple of 30 or 45? That's a multiple of 30. It's 30 times 4. Okay, so when I draw my diagram, where is 120 going to be? Do you know? It's going to be in which quadrant? 1 or 2? Yeah, so he said closer to 90, but in the second quadrant. Okay, so it might not be perfect, but I'm going to put 120 about right there. Okay, I'm going to make my triangle. And if I've drawn it reasonably well, you should be able to tell the short side and the long side. Okay, let's start with the side on the bottom. Okay. Gladys, is that the shorter side or the longer side?
The shorter side.
It's the shorter side. Okay. And how long is the shorter side when we're dealing with a 30, 60, 90 triangle?
Is it the 1/2?
Yeah, that's the 1/2. And that means this is the longer side. And can somebody remind me the longer side? Square root of 3 over 2. Now I know that x has something to do with a half. The y has something to do with root 3 over 2. Just make sure you get the positive and negative correct. Okay, so Becky, could you give me the coordinate for 120?
Square root of 3 over 2 and negative 1.
So you want to put the root 3 over 2, that's going to be the x value? Because you said that one first.
Over here.
Yeah, the other way around. Okay, but the numbers were correct. The 1/2 should be negative. But that's your x. And then your y, that's the vertical, root 3 over 2. Any questions on that coordinate? Hey, now it's just like any other problem. Find the tangent. Okay, Gabe, what's my formula for tangent? So I got y over x. And can you tell me what I get when I do that out? Yep. Square root of 3 over negative 1. And can you go any further with that? Well, you could write it so it's not a fraction. You could just put negative square root of 3. Most likely that's, if it's like a multiple choice question, that's what you'd see listed as the answer. Any questions on that one? Okay, since there's more options here, I'm not going to go through the 30 and the 60 in every single quadrant. Okay? But there's 6 questions I could ask you about this angle. I asked you for the tangent. Okay, the other angle that we could work with, maybe we'll come back and do one in a little bit, would be 150. 150 is the other angle that's a multiple of 30 in the second quadrant. And I could ask you 6 questions about that one, the sine, the cosine, and so on. Okay, but any questions about the 120? All right, so try that one. See if you can figure out the secant of 690. Okay, so keep in mind things we've said about angles that are too big. And remember, you're not doing all 6. You just have to do the secant. That's it. All right, so as we take a look at 690 degrees, before you even think about getting the coordinate, what's a good idea to do first? Yeah, let's subtract 360, and what does that give you? 330. So when I find the secant, am I dealing with an angle that's a multiple of 30 or 45? 30. So that already tells me I'm using the 1/2 and the root 3 over 2. The only thing I have to figure out is, are they both positive? Are they both negative? What's going on with that? And then what's the order? Is it the 1/2 first, or is it the root 3 over 2 first? Okay, so to do that, I'll draw my picture. It's 270. 360 is the same as 0, going all the way around. Where's 330? Do you know?
Quadrant 4.
Yeah, quadrant 4. And then can anybody be a little more specific in quadrant 4?
Closer to 360.
Closer to 360. Definitely not halfway. Okay, closer to 360. So just kind of estimate it. Make your triangle. And I should be able to tell the short side and the long side. Here's my short side, 1/2, and this is my long side. Okay, so the x is going to be a root 3 over 2, but it is a positive or a negative? It's a positive because we went to the right. And the y is going to have something to do with a 1/2, but is it positive or negative? Yep. It's going to be negative because we went down. So on the test, you'd get half credit if you gave me just this coordinate. Now the next part is I want the actual answer. What's the secant? Anybody get the secant? Devin?
Yeah, 2 squares is 3 over 3.
Yeah. Secant is when you take the x and you flip it, and you get 2 root 3 over 3. That's what you need to get full credit. The answer and the coordinate, just like in last night's homework. Okay, any questions on that one? Okay, does anybody want to do one with a negative with the angle? Anyone think that we need to do that one? What would you have to do after you change that to degrees to make it easier to work with? Well, Wendy? Do you think, because we don't want to work with negative angles. And which one? Add, right? Because it's negative, so you want to make it bigger. So you're going to add 360. Okay? And then from there, you'd figure out your coordinate. Okay, so any questions on how you change that to degrees? Add 360, and then get the coordinate. All right, so this diagram, I don't draw it all at once because it's a lot of stuff on the same picture, but that's basically everything we just did. All the red triangles are your 45s, and then your blue and green triangles are the 30, 60, 90s. And they're mirror imaged into every quadrant. So all your red triangles are the root 2 over 2s. The only difference between them is in quadrant 1, they're both positive. Quadrant 2, the x is negative. Quadrant 3, they're both negative. Quadrant 4, the y is negative. And then we've got the green triangle. That's your root 3 over 2, 1/2. And you can do that in every quadrant. And then the blue triangle is switching it. That's the 1/2 root 3 over 2. And you can do the blue triangle in every quadrant. So really, the only thing you need to know for the blue, the red, and the green triangle is what's right here. If you can just remember the 30, the 45, and the 60, mirroring it into other quadrants just means making one of them negative. Okay. The other thing that sometimes people forget about, because we did it the very first day, is the 0, 90, 180, 270. Okay. Those are the easy coordinates because they're just ones and zeros, and negative ones. Okay, so don't forget about those four. So for any angle that's up on the board, okay, and there's 16 different angles on that diagram, I can ask you any one of 6 questions about any of those angles. I can ask you for the sine, the cosine, the tangent, the secant, the cosecant, or the cotangent. The test is, I think this section of the test is about 10 or 12 questions. So I'll give you 10 or 12 different angles, and I'll ask you for one trig function per question. Okay, so you'll have 12 problems on the test, very similar to something like that. Good. Any questions on that diagram? Okay, but that's basically what we've learned all week up till right now. All right. So the second thing we'll take a quick look at is what happens if we have a point that's not on the unit circle. This circle right here, that's my unit circle. And I've put a triangle inside it, and that's roughly a 45-degree angle, but that doesn't really matter. Okay. So this is a length of 1. And these are the kind of diagrams you've been drawing all week. Any question on that diagram? All right, so now let's say we take that triangle. So the one in green is exactly the same size. And all I'm going to do is make a bigger version of it. Okay? The red triangle and the green triangle are what we call similar. They're not congruent because they're not the same size, but they're similar because one is an enlargement of the other. Okay? And what I'm going to do is put that one still starting at the same spot. And it's going to be on a bigger circle, okay, which I'm going to adjust it. It's a little too big. So maybe about like that. Close enough. Any questions on that? All right, so now this length in green, is this hypotenuse of the green triangle 1 unit long? What do you think? Jamal? No. The hypotenuse in red is 1 unit long. The one in green is much bigger. So it's a bigger version of that red triangle. Okay. Let's call it R. Okay. It's the radius from here to the origin. Okay. It's the radius of that bigger circle. So in the original, which, you know what, I'll try to write them in the same color. The original was the red triangle. The radius was 1. In the new one, that's the green triangle, the radius is now R. If I could change this R back to 1, Okay, in other words, if I could take this green triangle and shrink it back down, then I could do this problem just like I've been doing all week. But I have to work with a triangle that has a radius of 1, not r. It can't be bigger than 1. It's got to be exactly 1. So my goal is to take this triangle and shrink it back down so that it is back on the unit circle, and then we can go back to what we know how to do. All right. So let's say I had a triangle with a radius of 5. Okay, let's pretend that that green hypotenuse is 5. How many times is 5, if you compare 5 and you compare 1, how many times bigger is 5 than 1? It's 5 times bigger. So if you make 5 times smaller, it would be 1 again. What about if I had, let's say this radius was 10 units. How many times bigger than 1 is that? 10 times too big. So we would have to make it 10 times smaller. And it would be the same, it would be back to the size that we want. Right? So if it was, whatever I said before, 5 or 7, that's 5 times too big. You're going to make it 5 times smaller. If it's a 10, that's 10 times too big. You have to make it 10 times smaller. What if the radius is r? How many times too big is that? Yeah?
R.
It's r times too big. So we would have to make it r times smaller. Okay? And the way you make something smaller is you divide. You scale it down. So if I take 5 and I divide it by 5, that makes it 5 times smaller, turns it back into 1. If I had something that was 10 units long and divide it by 10, I just made it 10 times smaller, turned it back into 1. So if I had something that's r units, what am I going to divide it by to turn it back into the number 1? I'm going to divide it by r. That's the whole key. So in the original, we had 1, and now we have r. Divide by r, it makes it r times smaller. But if you're going to divide the hypotenuse by r, if you're going to make that side smaller, you have to make every side smaller. Right? If you're making the green triangle smaller, you have to scale every side down. So if the green triangle was x units long, and I scale it down by r, what is that side going to become? How long would it be? It wouldn't be x anymore. Think of how many times smaller we made it. Yeah? X over what?
R.
Yeah, it would become x divided by r. If you're going to divide the hypotenuse by r, you have to divide every side by r to scale the triangle down proportionately. You want to scale all sides the same amount down. And if the height is y, and you scale that down by r, what is the height of this triangle going to become? Devin?
Y over R.
Yeah, it's going to be y over r. So by doing these two things, you can take a bigger triangle, scale it down and make it smaller, and you're going to force the hypotenuse to be a 1 again. Right, so what I'm going to show you, basically, let's look at, keep these two things in mind. And I'm going to show you the 6 formulas, very, very similar to what we already know, except in these formulas, everywhere we had an x, we now have to make it an x over r. And everywhere we had a y, we're going to make it a y over r. That's the idea of scaling that green triangle back down to a smaller one, so it's back on the unit circle. Okay, what was the definition of sine originally? Yeah, it was y. And what did I just say we're going to replace y with? Yeah, we're going to replace it with y over r. Okay. Cosine was x. We're going to replace x with the scaled down version, x over r.
Why didn't it change it?
Yeah, we're going to look at why didn't tangent change. Tangent was y over x before, it's y over x now. Here's the original, y over x. What did we just change y to? We changed y to y over r. And what did we change x to? X over r. Now, when you divide two fractions with the same denominator, what did I say happens to the denominator? It cancels. That's why tangent stayed the same. Now, if we know the 3 on the left, we can get the 3 on the right exactly the same way we have before. What do you think the cosecant is? Yep.
R over 1.
It's r over y. Okay. How about the secant? R over x. And the cotangent? X over y. These are the 6 formulas for doing trigonometry on any circle. Not just a circle of radius 1, but any circle. Now, watch what happens. Don't write this down because I'm going to erase it in a second. But watch what happens if I change all the r's to 1s. Okay? That's the unit circle. If I make that a 1, make that a 1, make that a 1, and make that a 1. What happens? What are these formulas right here? Those are the original formulas. So the formulas that I taught you on Monday were really these formulas. But to start out with, I made it easier by letting r be 1. I could have let r be 2, 3, it doesn't matter. 1 is an easy number to work with. Okay, so when we did it on Monday, the radius was always a 1. Now the radius can be, bless you, anything you want. Okay, so with this kind of problem, the way they would do it is they're always going to give you the coordinate. Always. So if they give me the coordinate, what 2 letters are they always going to give me? They're always going to give me x and y. But besides x and y, there's one more letter I need in these formulas that I didn't need before. I need r. Okay, so let me make that a little bigger. And let me draw that point on the circle, okay, roughly. Right 5, up 12. Okay, so just estimate it, go right a little bit. Make it look like you went up more than you did right. So my goal is to figure out that. Is that distance going to be 1? No. How can you tell that this distance, just kind of eyeballing it, it can't be 1? You want to see how we can tell it's definitely not 1? Oh, Riley? See? Look at what I've labeled. What did I label there? Yeah, what is the coordinates of it? 5, 12. This point represents going right 5 and then up 12. So is there any way that this could just be 1 unit long? No. Think about a grid. If you go right 5 units from the origin and then you go up 12, there's no way the distance is going to be 1 unit. You've gone to a point that's very far away from the origin, relatively speaking. Right? So then how can I find this distance? That's my radius of the circle. And if you're not sure, think about something we could draw that we draw a lot in Trig to help us. Yeah, Jacqueline? Right, so Make a triangle out of it. All right. And what do I know about that triangle that I just drew? I know a couple things about it. Yeah?
That it has a right angle.
Okay, it has a right angle. What else do I know? Yep. That I don't know. It might be, probably not though. It's probably gonna, we don't know what the angle is gonna be. Yep.
Show sides, X and Y.
We know the sides. How long is the bottom?
5.
Yep. And how tall is it? 12. We know the base and we know the height. So how can we get the radius of that triangle? How would you do it out? What would you do? Yeah, that's the only extra step in this problem. Just do the Pythagorean theorem with these two numbers to get r. And then you can do it just like a normal problem. So we've got 5 squared plus 12 squared equals r squared. What's 5 squared? And then 12 squared? And if you add 144 and 25, what do you get? 169. That's not the radius. That's the radius squared. So what's my radius? 13. Once you know that number, now you know r, you know x, and you know y. Just do it like a normal problem. Okay, so let's look at sine. Sine is y over r. Okay. What's y in this case? Well, Marcos? 12? Yep. Over what's r? 13. Okay. There's the sine, 12/13. Okay. What's my formula, Emma? What's the formula for cosine?
Just the value of x.
Okay, in the original, but is my radius a 1 here?
Oh, no.
No. So we got to use the formula I have up above.
X over r.
Yes. What's x?
5.
5. And what's r?
13.
13. So there's cosine. In the last one, we already saw a tangent. It stayed the same. So what's going to be the answer for tangent? Got it? Yeah, it's going to be y over x, or 12 over 5. Okay, so only extra step when you have a coordinate that's not on a unit circle, use the Pythagorean theorem with these two numbers. That squared plus that squared equals r squared. Okay, I picked one that came out nice this time. 5, 12, 13. It's nice numbers. It is possible 13 could come out to a square root. If that happened, we already know how to deal with square roots in the bottom. Okay, but this time it didn't. So any questions on how we found r or used it in these three formulas? Now, I didn't do the 3 on the right, but all you'd have to do with the 3 on the left is what? Flip them. Yeah, find the reciprocal. And you'd have the 3 on the right. Okay, so any questions on that? Okay, so the last thing, the easiest thing is, if we don't work with angles that are multiples of 30 or 45, then we're going to use a calculator. So all you have to know is how do you type it in, like what buttons do you press? Okay, so let's find the sine of 18 degrees. You know what, let me use this one. Okay, first thing I have to do is make sure that my calculator is in the right mode. Okay? We're going to do some problems in radians, we'll do some problems in degrees. What mode should I be in for this problem? Degrees or radians? And what tells me that? Yeah, a degree, a little circle. All right, so first thing on my calculator, I go to mode and I press degree. Okay, every calculator is a little different. If you If you've got one like this, a lot of people have this one, you've got a button at the top that says DRG. If you press DRG, 3 choices come up. You can use the arrows, and it'll underline the choice, and then just hit enter. And what's nice about this calculator is it tells you in the lower right. If it says RAD in the lower right, you're in radians. If it says DEG, you're in degrees. Okay, so put your calculator in degrees, and then just press sine 18, and then hit enter. So if you did it right, you should have gotten 0.309. Anybody else get 0.309? Just make sure you know how to do it, because I won't help you the day of the test. If you say, I don't know what to press, okay, now's the time to ask me. Okay, so 0.309. Let's try cosine 356 degrees. Okay, so looking at the problem and looking at the mode my calculator is in, do I need to change the mode? No. I'm doing a problem about degrees. My calculator still is in degrees. So you press cosine 356 and hit enter. Now, some calculators, I don't know if anybody has one in here, but some of them work backwards, and it's a little confusing. This calculator is like mine, okay, that you would use. You press cosine first, and then 356, and then enter. This calculator, I have to put 356 in first, and then press cosine. Okay, so you've got to figure it out on your calculator. Do you press cosine first, or do you press it last? Okay, each calculator I have on the board is different. Okay, but it's the same answer, 0.998. Anybody tell me how I would type that one in? Tangent, what's on the board? Yep. Right. Simple thing a lot of people would miss. They forget to change to radians in this problem. Okay, you just have to look at the test and either read the directions, or if it's a multiple choice question, look at my answers. Are my answers in radians, or are they in degrees? Something like mode. Change to radians. And then press tangent, 2.4, and you should get negative 0.916. Okay, if you're getting the answers I'm getting, you're doing it correct. If you're not getting any of these, come have me look at your calculator, and I'll help you out today.
You change your radians?
You press the DRG button at the top,
Oh, okay.
and then you'll get to use your arrows, and then underline it, and then hit enter. Any questions on that one? Yeah.
Is there a way to do cosecant, secant, and cotangent on this calculator?
Yes. So if you look at the calculator, you don't have a button that says CSC. Okay, whether you're using a graphing calculator, if you're using like the one that I have, there's no button that says CSC. But you can still do it. How would you do this normally? How did we learn that you do the cosecant? You flip it. What do you flip? Well, I need something to start with, though. I'm not sure. What do I start out with here? To find the cosecant. Yep. Find the sine. Okay, so if you want to find the cosecant, the first thing you want to do is find the sine of 247, and then flip it. So the cosecant is 1 divided by the sine. That is the only way to type in something like that. Okay, that's how you type in cosecant. Okay, and it's 1.079. This is actually an exact answer. That's rounded off. You got 1.086. I'm going to check my mode, make sure, thank you, yep, because
I got negative 1.8.
Yeah.
So on that last problem, what did I do wrong that I keep mentioning not to do? I didn't change the mode back. So it's negative 1.086. How about secant of 6? Just tell me what I would have to do based on how my calculator is set up right now. Yep. First thing I would do is change to radians. And next, how would you type in secant? Yep. So how would you type it?
You do the cosine of 6 on the bottom and on the top.
Yep. Cosine of 6 on the bottom, 1 on the top. What's the last trig function? Cotangent. How would you type cotangent of 13? You don't have to give me the answer, just how I would get the answer. Devin? Yep, I'd have to change my mode to degrees if my calculator wasn't in degrees. Yep.
Negative tangent.
1 over tangent. Okay. Make sure you understand how to do these, because most people do the sine and cosine ones fine. But I always put 2 or 3 of these on the test, and there's always a couple people that get all these wrong because they don't know how to flip it. So if you have a question, just ask me before the test.
Can we use a reference sheet?
Yes, you can use a reference sheet. Okay, so the homework, tonight you need a calculator 67 to 81. Those are all calculator questions. You just have to type them in and hit enter. 49 to 57, those are like the first ones I did in class. Just do the odds. 67 to 81, you need a calculator, and that's all. And then 83 and 84, those are like the last 2 problems we did with, you had to use the Pythagorean Theorem to find the radius. Okay, so tomorrow we'll have our test, but we'll go over the homework first. Okay, I'll also be after school today if anybody needs to stop by for extra help.